built this Grim Reaper for my Halloween display that uses an Arduino Uno, a couple of cheap IR cameras on a board, and a servo to track folks as they walk by and turn the Reaper's head to face them. It was a fun project. I'd like to share with you how I did it. The sensor I used for this project is the AMG 8833 on a board made by Adafruit. This camera is very low resolution with an 8x8 pixel array. The Adafruit website has lots of good information on how to use this board, including how to use the output to make a thermal display. But for this project, I'm not using the display, but rather using the data to determine the location of a heat source and control the servo to point at it. I bought this board a couple of years ago, and since then the board has changed a little. Besides the reorientation of the camera on the board, the SDA and SCL via locations have switched. However, you can avoid soldering to these vias altogether if you use the stemma connectors that are available on the new board. The back of the board has a couple of pads that can be used to control the I2C address. The default is the unbridged, which gives the 0x69 address. Bridging these pads with some solder changes the address to 0x68. I used two of these cameras, so I had one of each. I used a 9-volt battery pack to supply a buck converter that puts out the 5 volts that I used for the Arduino and the servo. The Arduino is connected to the AMG 8833s with the power at the VIN and ground vias. The AMG 8833 boards are very low power units, and so the Arduino is perfectly capable of that. But the servo is powered directly from the buck converter since it has a higher current capability than the Arduino. I put the two IR cameras on a breadboard and wired it up to my Arduino. Connections are pretty simple. There's a 5-volt positive, a ground, an SCL, and an SDA. A few libraries are needed for this sketch. The wire library is used to communicate with the IR cameras. The servo library is needed to control the servo. There are also two special files. The Adafruit AMG 88XX Dual library is a modified version of one available from Adafruit that I have added that _dual to the name. Also needed is the Adafruit AMG 88XX Dual.cpp file that goes into your library folder as well. Both are modified by me to allow the address of the IR camera to be passed to them as a variable. A link to the sketch and the libraries is in the comments below. Here I have soldered the wires to the needed connections. I modeled a holder for the cameras that has two faces angled relative to each other so that the last column of pixels for the first camera is parallel to the first column of pixels of the second camera. The holder has bosses on the back side for fasteners and 4 tall bosses to attach to our Arduino board to. I placed it in my slicer in this orientation to minimize the supports needed, and printed it on my Ender 3 V2. Once printed, I installed the two IR cameras. The camera locations are offset vertically to allow the wires on the backside to pass by each other. Then I attached the Arduino and connected the wires. This took a couple of iterations of removing and reinstalling the Uno to get all the wires connected and stowed. Next, I modeled a mount for the camera holder. And a base to hold it, the buck converter, and the battery pack. To power the Arduino and the servo, I used this UC-tronics DC buck converter. It uses 9 volts to 36 volts either through this jack or through terminals, and outputs the 5 volts in this USB or these terminals. I power it with this 9 volt battery pack and power it through the jack. And here it all is together. On the top here we have the Arduino Uno and the 2 IR cameras on its mount. That's mounted on a clevis that has a wing nut that adjusts your elevation. It's powered through the USB port on the Uno and through the USB output of the buck converter. Also on the output of the buck converter are the red and black wires for the servo. Here in the base, there's also a battery pack. The battery pack is just a 9 volt battery pack of AA batteries. On it, it has a jack that connects to the jack input on the buck converter that powers the system. The servo power and signal wires are bundled together here in a long length with pins at the end, so it's easily connectable to the servo. Now I modeled the servo holder that also mounts the servo assembly to the PVC pipe that it will use for the body of the Reaper. The bottom clamp was modeled. And then the bearing assembly housing that supports the weight of the head frame. The printed servo holder has features to hold nuts that provide the threads that hold the assembly together. Here I'm using a bolt as a jacking screw to pull the nut into the tight fit of the 3D printed part. I then install the servo into the holder that has a cutout for the wire to pass through. There are 4 holes that are sized to accept special self-threading screws designed for plastic parts. The bearing holder is printed, and then the bearings installed. I designed a coupling with slots to accept posts on the servo to allow for any misalignment between the servo and the bearing axes, both radially and angular. I pressed a nut into the coupling and threaded it on the shaft, which is a piece of threaded rod, and tightened it against the jam nut. The slots for the nuts that go into the servo holder to allow the clamp to be attached were modeled too large, so I made these adapters to put the nuts into that made up the difference. Then I pressed the nuts into place. I then assembled the bearing holder onto the servo holder, aligning the 2 screws that I attached to the servo horn. With the assembly done, I added a couple of nuts on the output side of the shaft, and a large fender washer that I clamped between two nuts. This washer is what I would later attach the head cage to. This arrangement allows me to raise or lower the head cage as needed. I cut the excess thread off after I had the height right. Here you can see the two posts from the servo horn interfacing with the coupler. I used 1 1/2 inch PVC pipe for the body frame, mounted to a plywood base, and some chicken wire to fill out the body. The servo assembly is mounted at a slight angle to mimic human anatomy, and the head cage is attached. The head cage is made out of 1/8 inch steel rods that I bent by hand and formed to fit my own head, then welded to the fender washer. A hook is screwed in place at the end of the arm to hold the lantern. The gown and cape will cover the hand, so nothing fancy is needed here to replicate the hand. The frame is attached to the plywood board by bolting a couple of end caps loosely to the plywood with flathead screws from the bottom side of the board. Then a couple of turnbuckles are attached to the PVC pipe and to the board. Wing nuts are used, and the PVC is not glued to the end caps, so the frame is easily removed from the board. Turnbuckles are used so that I can easily adjust the angle of the board to the frame to compensate for any slope in the yard or driveway, as can be seen here. The uprights and the T's are glued together, as is the section between the T's, but the rest of the connections are not glued and are held in place by panhead sheet metal screws instead. This allows repositioning and disassembly of these joints as needed. And here's the first test of the system outside. It sees me, and then looks off into the distance. It seems to see me, but there's something else drawing its attention. I'm the only one outside, so I needed to investigate this behavior. Here's an image of the view of the IR camera taken with a visible light camera, and then the IR data is superimposed over it. The ground is warm, the house is less so, and the sky is cold. The warm area to the right, I think, is from a streetlight pole just out of frame. If we look at a few frames of data as I walk in front of the camera, we can see that my body is not any warmer than the ground in some locations. Only as I walk into the middle are my legs a few degrees warmer than the surrounding ground, and this is only because I'm wearing shorts. Using the maximum temperature turns out not to be a good algorithm for detecting a person in this scenario. I tried summing the rows of each column and using that value, and while it was much better, occasionally it would still look off to one side or the other. So I decided to compare the sum of the rows in each column to the sum of the last frame and calculating the change in that value between the current frame and the last frame. This worked well as the difference in change when a person walked into frame was large compared to the minor changes of things like tree branches waving in the wind. Even as I just walk into frame on the right, the change is significant. Because of this, I also added a threshold, over which that change must be greater, in order to send a new position to the servo, and that removed all of the spurious motion. With that solved, I moved on to the gown and cape. I used a couple different patterns. This one is the M7229 from McCall's, and I used the AH gown. The instructions have you putting the sleeves end to end like this. Because we lengthened the sleeves, this second one moves down a little bit, and so you have to account for that in the length of the fabric that you buy. For this particular pattern, for the AH and the extra large, which I used, it calls for 4 7/8. I substituted 6 yards, and that was just enough. In the instructions, one of the last things it has you do is sew this back seam, but we skip that step to leave it open in the back like a hospital gown, so it's easier to get the gown on the frame. The second pattern we used here was another McCall's. This one is the 4139, and we sewed the B cape here, which is the unlined cape. And the only thing that we didn't do in the instructions is we didn't sew the hems. The material is a black burlap, which was nasty to work with as it shed tons of fibers. I used the patterns as is, except for the sleeves, which I needed longer to cover the hand. I added some pattern paper from an unused part of the pattern and drew new lines for the sleeves, starting from the same place on the shoulder and ending farther down the pattern, but at the same width as the original. Then I sewed it all with upholstery thread. The frame is painted black, so it can't be seen through the loose weave of the burlap. Okay, now that we have them all painted black, it's time to dress them. First thing I'm going to do is the hood comes up around the back side of these wires here, and they are exposed if you don't cover them. So I built this little sock made out of the same burlap material, and it goes over the top here and has an extra flange to cover up this portion of the mechanism so it's not visible. So let's put that on. All right, the next thing to do is put the gown on. As I mentioned earlier, I sewed the gown per the instructions, except I didn't do the back seam. And the reason for that is to have it open in the back to make it easier to put on the structure. So you can see that this right hand sleeve will not go over the hand with the elbow and shoulder in its current position. So I'm going to loosen up the screws that I talked about earlier, and it allows me to move the arm to get this sleeve on easier. This section covers up the neck, goes on the inside. Make sure that there's enough slack in this neck piece here so the mechanism can turn. For the belt, I simply have just a piece of jute rope. Now we place the hood. The piece of armature wire that's here on the inside of the hood is easily bendable to get the shape that you're looking for. then finally, we take this cheap battery-powered lamp and place it in the hand. A hook that's hanging from the end of the pipe. And then we arrange the sleeves of both the gown and the cape. So there's some partial coverage, but not completely obscured. And then finally, to put a little wear and tear on it, I bought some of this freaky fabric from the local Halloween store, and we'll drape a couple of pieces over it to give it a little more tattered look. One of the things I did on the cape was I didn't sew any of the hems, and the reason for that is that we needed the ends to look tattered. So now I'm just pulling some threads along the edge to give a more tattered and time-worn look. Sometimes a couple little snips will help you with that. And just keep on doing that until you're satisfied. And here it is, all finished, with the new algorithm working well. It does a good job of tracking me as I walk by. As I was filming, a delivery truck passed by, and I was happy to see that the IR camera was able to sense it and track it as it passed by. It stopped next door, and since it wasn't moving anymore, the algorithm counter eventually reached its limit and the servo moved to the middle as designed. Success! I ended up putting it at the end of my driveway to make room for my other displays. Have a look.
And ghoulies from last Halloween.
Thanks for watching. I hope you have learned something useful, and if you have questions, please leave them in the comments.